Let's start from the very beginning. What is Docker? Whenever you install or use Docker, you are not using just a single component. As you can see right here, Docker is composed of many different parts, and these are used depending on what you are doing when you are using Docker. In a nutshell, you have basically two different trees that you are going to execute. One is for managing the images and the Docker files. In this way, you are defining the different steps of the Docker file, creating the images, building the images using both the Docker files and the build context. And in the other hand, you have this section right here that is used every time you interact with Docker containers, every time you run a Docker image in order to create and run a new Docker container. Whenever you start using Docker, you are going to start by using a Docker file, and you're going to put instructions in that Docker file, so then you can build a Docker image using that specific Docker file. You will be working locally with your Docker file until you finish doing that, and at some point you are going to execute Docker build. At that point, when you execute Docker build, you will be interacting with the Docker CLI tool, that is this one. This interface is used to execute Docker commands like Docker build, Docker run, or any other command that you might be running. And as you can see, this Docker CLI interacts with the Docker API. The Docker API is basically a REST API that acts as a bridge between the CLI tool and Docker Desktop, between these two clients, and the Docker daemon, the Docker D. This is the core service that manages container, images, networks, volumes, everything that you are interacting with every time you use Docker. It receives instructions via the API and delegates tasks to the appropriate components like builders or the container runtime, depending on what you want to do. In our example, since you are doing Docker build in order to take a Docker file and build a Docker image, in this case you are interacting with the Docker CLI, you make a request to the Docker API. From here, the Docker API talks to the daemon, and the daemon sends that request to the builder itself, that is the Docker build subsystem. It interprets the Docker file and build images layer by layer. BuildKit is the modern and more efficient builder introduced by Docker, and it is often enabled by default, depending if you're using Docker Desktop or the Docker version that you're using. So in here, we are managing all the different layers for the Docker file. We receive both the Docker file and also the build context that you send whenever you execute Docker build. And from this, builder is sending this Docker file and the build context using the BuildKit workers that are the executors that perform each build step, such as run, copy, and CMD. They interact with the file system and generate all the different layers for the final image. So as you can see, the build workers are interacting with the Linux kernel, and finally the Linux kernel itself is interacting with the operating system. So in here you have your operating system, whatever system you are using right now, Windows, Linux, Mac, or whatever you're using. And as you can see, in this case, we have a Linux kernel. Docker is using a lot of features from this Linux kernel, and as you can imagine, this kernel is not natively available in Windows installations or macOS installations. So in this case, Docker is installing a Linux virtual machine in order to have a Linux kernel to provide all these different features from here. This kernel provides all the core functionality for the containers and for building the different images based on the operating system that you are using. It is using the namespaces for isolating the containers, it is using C groups to control resources, and also overlay.fs or union.fs that is managing the different layers for the file system. So as you can see, whenever you run Docker build, what you are doing is from the Docker CLI interacting with the Docker API. From here, the API knows that you want to build an image, so it goes to the builder or BuildKit depending on what version of Docker you have. From here, it is using all the workers, and these workers are interacting with the Linux kernel and finally with the operating system, so you can build the Docker image. At the end of this process, you have a fully functional Docker image. Now, whenever you want to run a Docker image, so you want to use a Docker image to create a new container and run the container, whenever you type Docker run in the CLI tool, or you do it using Docker Desktop, you are using any of these two layers, both the CLI or the Docker Desktop itself, to interact with the Docker API. In that case, Docker API is talking with Docker daemon, and in this case, we are going to container D. This containerd is a runtime used by Docker to manage the container lifecycle operations like start, stop, pause, or any other action that you might execute against a given container, and it abstracts many low-level container functions for you to use. Once we call containerd, Docker is using runc, that is the low-level runtime that actually starts containers. It creates the Linux namespaces and cgroups to isolate the container process, so you can see that containerd uses runc under the hood. But runc is the one using the namespaces, the cgroups, and overlay.fs from the Linux kernel. Depending on the operating system that you have, it will be using the Linux virtual machine that Docker installs in Windows and macOS systems, or it will be interacting directly with the Linux kernel if you are on a Linux environment. So as you can see, Docker is a whole environment composed of many different parts that are executed depending on what you want to do.